Hey everybody. This second page is almost exclusively second semester. This will probably go a little bit faster than the first page because even though it looks like there's a lot, there's many fewer formulas. So the first is basically this separates everything into inference. So it says inferential statistics here, but this is basically the page of inference. So for one population, it gives you the means here. Now what this means for all four of these is this is an indication of unbiased. These are unbiased estimators because the mean is equal to the true population value. So these are unbiased estimators. So in this course we focus on the unbiased estimators. If you continue studying statistics, you will go a little bit beyond just these. Actually, you can go way beyond these. So you will end up using this formula in a one proportion test for proportions. So the calculator command where you might end up using this formula is test 5, 1 prop z test. Then here, and the reason you can use this one is from the null hypothesis, you know p. But here, this is used for a confidence interval because you don't know p, so you have to replace p with p hat. This is A, these are the 1 prop z interval. So in the checks and everything, you end up using p hat because you don't know p. And remember, confidence interval, you're estimating p. So up here, I'm going to put it, hypothesis tests, you're testing a claim. And confidence intervals, you are estimating a parameter. So this formula gets used with the test, this formula gets used with the interval. The problem is this one only ends up getting used in probability questions. So up here, you're going to end up using this one where you replace p hat 1 and p hat 2 with confidence intervals. So this is choice B, a 2 prop z interval, and you should know how to use all of these. I'm going to put in, since we now have both intervals, please take note in the calculator command for the intervals, x is the number of successes. Because the way it asks for it is it asks for x and then n is the sample size. And then in the case of 2 proportion, it will be x1 and n1, and then x2 and n2. But x is the number of successes. It has to be an integer. So know how to do that. You do need to show, or at least in the past, you've had to show the calculation of p hat. You can't just use the calculator command, although pretty much everything else can come just from the calculator command, even though I required plugins. So if you use these commands, write that command down on your paper. So, and then you don't need to show the plugin step. So now here, the null hypothesis with proportions is generally 2 proportions are equal. So this formula where you must show this calculation is used in 6, a 2 prop z test. And the prop here stands for proportion. So you'll notice for all of the proportions, prop, 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 prop. Okay. So then we have all the formulas for means. Now For means, we will never pretend that we know sigma. So we're always in the standard error column, not the standard deviation column. Now, one thing here, and I'm going to put it in blue, sampling distributions for means. For either hypothesis tests or confidence intervals, you do need to list degrees of freedom used. So make sure you do your degrees of freedom for your means, that you don't have degrees of freedom with proportions. So standard error of the sample statistic. This formula gets used in two cases. For the interval, it's option 8 under stats tests, it's the t-interval. And for hypothesis test, it's option 2, t-test. You will not touch z-interval and you will not touch z-test. Here, please take note, your degrees of freedom is n minus 1. And then in the two-sample case, the interval is option 0, 2-samp t-interval, and then option 4, 2-samp t-test. You will not use a z-interval or a z-test. And for the two-sample situation, you will use degrees of freedom from the calculator, and do not pool. Do not pool. So pooling assumes the standard deviations are the same. Well, here it's listed as variances. So pooling would assume, say, the variances are the same. You don't want to assume that, so please don't. And then the last thing, which is the inference for slope, we did not get to. It will not be covered on the AP Statistics exam this year. Okay, this video was much shorter. Please also watch the video on StatsMedic. They probably have a little extra stuff to say. Please be aware, I know some of you have emailed me already, stuff that I required you to show during school is not required to be shown on the AP exam. We will get to what all of that stuff is. And that's like, you can use these lots more than I was comfortable with during the school year, the calculator commands. The final things I do want to mention is just the next piece here is the normal table. I don't use it. Some of you do, and that's nice. What you have to realize is if you're ever using the inside of the table, if you're starting with a proportion, that's something where you're using inv-norm. And then the sides are the z-scores. I would recommend learning how to use your calculator. The two calculator commands you need to know how to use for this are normal CDF. Be very aware of this command. This one has come up a lot all year. So now how to use normal CDF, lower bound, upper bound, mean, and standard deviation. Writing normal CDF is actually, it will fit the requirement all year. I told you you had to tell me you had a normal distribution. Writing the command actually identifies it as a normal distribution on the AP exam. The other command is inv-norm. You use inv-norm when you have an area and you're trying to get the observation or at least the z-score. And so you can do it area, I usually only use it area and leave mean of 0, standard deviation of 1, and that'll give me a z-score. So if I do then mean of 0, standard deviation of 1, this gives me the z-score for that area. Or you can do it if you actually already know area mean, and standard deviation. This will give you the observation value. So just watch the area. Inv norm always shades below. Oh, that's not true of those of you with the newer calculators. The newer calculators actually shade above and below. So you can, and in that case, after the sigma, write whatever your calculator says. I don't have one of those calculators. But if you have the older calculators or it doesn't give you the option left, right, center, write whatever it says. Okay. And that is the normal table, and then we've already gone over the t-table. Hopefully this helps you out. I will talk to you again soon.